All right, guys, we're going to do a little volume experiment here. Hopefully you can see this and see what goes on. What I'm needing to review you on is we've been doing the volume of these shapes right here. These all have a base on one end that is identical to the base on the other. And so we say that this in between the two bases is the height. Even here, this is the one we've had lots of conversations with, even though it's sitting like this. Sometimes these two down here on the end are the bases. And then, so that means the height is in between them. They will sometimes have a height of a triangle down here, but the height of the prism is stood up between these. So we could find the volume of these pretty easily by doing the area of whatever this rectangle is on the bottom, and then multiply it by this edge right here, which would be the height between those. Okay, so these are all these have something in common. They have two bases. They have a base on the bottom, a base on the top that's identical. All right. So what we're about ready to do is venture over into finding the area of one of these. And so what's different is it's only going to have one base. Okay. And so what I want to do is a little experiment and show you and compare it with this other shape over here. If you can see, these two actually are identical in height. So if I was to do the height of this, technically the height would be inside here. All right. So if I could draw a point from this apex straight down perpendicular to that would be the height that's inside there. Over here, you don't necessarily have to do that because this height on the outer edge is the same as the height throughout the center. So heights in here are perpendicular inside. That would be different than this edge. So just to review, they are the same height. Okay. And then the other idea here is that these actually have the same base. So I can put these together. I could compare them and show you that base on the top and the bottom is identical, even this way. This is the same base. All right. So the experiment is this. Okay. How much volume does this one hold compared to this one, even though they have the same height and the same area of the base? All right. So remember, we could think of volume is really kind of like water. That's what a measurement of volume is. So we're gonna try the little experiment right here and see how much water this one will hold. And hopefully you have some predictions in mind already. I'm gonna try not to make a huge mess. Get as full as I can. All right. So then I'm gonna take this water. I'm gonna start to see how many of these it's gonna take to fill up, again, with the same height and same base. So if your guess was 2, you were wrong. Is it going to be exactly 3? Wow. I think it's held. Okay. We have exactly 3. It's in there. None of us ran over the top yet. Of course, as soon as I move this, it's probably going to. But anyway, that is the big, oh, I got to be careful here. That is the big idea. It takes exactly 3 of those to fill up the volume with the same base and the same height. So we have this formula. I'm on page 21. That ought to be pretty straightforward for us to figure out about now. That it's going to be 1/3. All right. So really, nothing has changed. We just have to remember at the end of our regular routine that we've been doing that we're still going to do the area of the base times the height of the pyramid, and we have to divide by 3 now because it's 1/3 of that volume. All right. So let's just work through a few of these. It's really straightforward. It's not actually that difficult. Let me grab a calculator real quick. Okay, so the first one's pretty straightforward. right? Area of the base times the height. Well, the area of the base, which I'm going to represent that as capital B and capital H. Well, capital B would be a 12 by 12 square, right? Area of the base. And then the height, obviously, is perpendicular inside there is 9. So I'll multiply all that out in my calculator, and the only thing I'm forgetting to do is to do 1/3. So I probably should put my 1/3 out here. All right. Or just put in your calculator, you can put divided by 3, because that's really essentially what you're going to do in your calculator. I'm going to do 12 times 12 times 9 divided by 3. And so my answer right here would be 432 cubic feet. That's how we get this number right here. All right. So pretty straightforward. The area of the base times the height divided by 3. Now, you are going to come across some problems that look like this. Okay. This one is a square pyramid. If it doesn't, it says they have square bases, and we will usually tell you that. But this 13 is on the slant height. So this is that L that we used on a cone, also is slant height. Or that's not the regular height, which would be in here. There's capital H for that. So what you ought to be able to picture inside here is that this is what we need, and I need to complete this triangle over here, which would be halfway across a square. So I know that this is 5, and then I know my hypotenuse is 13. So I would have to go over here to the side and do some Pythagorean theorem, like so. And you figure out that the height of this thing is going to be 12. Height of the pyramid would be 12. Then I'm ready to do my volume formula, which would be area of the base, which is a 10 by 10 square, times the height, which is 12. Don't forget to divide by 3 because it's a pyramid, right? 1/3 of the volume. That's how we get that answer. Okay. One more. Let me show you one down here at the bottom. All right. This triangle right here, this is a right triangle on the base of this. So if I still continue to do area of the base, all right, so you're going to have to think a little bit now that I'm going area of the base. I'm thinking about the area of the base of a triangle, which would be this formula now, not a square. We've been using this one for a square. All right. And by the way, here's my big formula I'm using. I got to do this for the area of the base of a triangle. So I am fortunate enough that this is a right triangle, so it's 6 by 8. I can use those for the base and height of the triangle. So it's going to be 6 times 8 divided by 2. That's going to be the area of the base. And then I'm going to have the height of the pyramid, which is 18. Then I can't forget to divide all that by 3. You're just going to have to be careful typing all that in your calculator. But again, this in parentheses represents the area of the base. And this is how I want you to show me your work. I know you'll go to your calculator after this. All right. So there are a few more of these over here on the next page. I will do one more. This particular problem right here is doable. That is a triangular prism with a triangular pyramid stacked on top. It's actually these shapes that I had here that I took that picture with. But it gives you all the dimensions, and it says to find the volume. Well, let's talk about the one where it's a regular triangle. We were fortunate enough on the previous page that these were right triangles on the base. All right. But a lot of times the pyramids are not like that. They're a regular triangle on the base. So this is the one that requires a little bit more work, and you're going to have to do it down here on this one. But I'm going to do this one. So the big idea here is to do volume, area of the base, times the height, divided by 3. Well, the area of the base is the problem here, because the height is pretty obvious. It's 9. I know I'm going to divide by 3. So what I need to do is take that base off. And if you take it off and look at it, it's more like one of these. I know it's drawn in 3D, but it says right here, the base is an equilateral triangle. So if I traced this equilateral triangle, sorry about that. All right. So I got to do my area formula right here would be, I'm going to use little b and little h divided by 2, because this is how we did a triangle. Well, the base is 6. It's equilateral. So all of these are 6 by 6 by 6. So I know that the base of the triangle is 6. It's the height of the triangle that's the kicker. Remember, heights are perpendicular even inside a triangle. So since this is isosceles, it does cut that in half. This is going to be my height. You can see some similarities to the other problem. You are going to have to do 8 squared plus 3 squared equals 6 squared. And you're going to figure out here that the height of this one, let's see, that's 36 minus 9, which will be 20. It's the square root of 27 when you do Pythagorean theorem. So I want to put that number there. This right here is what represents the area of the base. So what I mean by that, I'm talking that entire base that's on the bottom of this shape right here, right? So this is what needs to go over here, area of the base. So you got to be organized on your paper. I know 6 times the square root of 27 divided by 2. That's what goes in there. Hope you can read that. 6 times the square root of 27. So this is what you all need to get all typed in your calculator. It's a little bit of a challenge to get it typed in there, but you can do it. You can do it all at once, actually. So I'll try it right here and show you. I'm going to do 6 times the square root of 27. And since I have that triangle right there, I'm going to hit this over this little button. I'm going to hit this button right here and to get out from underneath the radical sign. Then you can do divided by 2, and you can still do times 9 divided by 3. It'll get it all in there, and then you'll get your 46.7 or 46.8, actually, I should say 8 cubic millimeters. All right, that is the volume of a pyramid.